Heidi ho, mathletes. I'll be running the mic today. That microphone, though, audio quality. Let's turn it up. Hopefully, the quiz went well for you. We're going to try and finish up day 3 and day 4 today. Just as a reminder, I will see you on Friday where we will do the last lesson of this unit. Next Tuesday, we review, and next Thursday is our test. I will be after school Thursday and Friday this week. Uh, this is your best opportunity. Again, we have 2 tests, so hopefully you got SOHCAHTOA down. Now we just have a couple more things to kind of pop up as we go through this. So I'm on page 15 in the notes. All right. And we kind of went through a little activity, typing some things in our calculator. We saw that sine and cosine gave us the same value if they added to 90. Okay. So if I see cosine equals sine, that tells me that the angles equal 90 degrees. So I see cosine equals sine. I'm going to add the 2 angles up to 90. Okay, so the first angle they have an x. This angle they're writing as 90 minus x. And this is like the general form, the way they show it. Okay, because this negative x and this positive x would cancel out, and you've got 90 equals 90. So I'd like you to take a second and try and do all the problems in 8. That was supposed to just be a little refresher course. You're trying to find theta. All right, that's just a symbol that holds a place for a, it's usually used for an angle. Okay, but you are trying to solve each of these. Now fast forward the video, solve each of them. Okay, and I'd like you to know this last one, you could think of this as 1 theta over 3 plus 10, and then you're adding it to another 1 theta. Okay, and I would use my calculator and I would add 1/3 and 1 to find the coefficient in front of the theta. All right, but I want you to pause it, rip right through this, see if you can figure out what those angles. All right, so beep bop right through some of these. Okay, so for the first one, I mean, you might even be able to see it. I subtract 25 and theta should be 65. Second one, I subtract 80, theta should be 10. Okay, now I've got 2 thetas plus 10 equals 90. That means 2 thetas equals 80. So 1 theta would be 40 degrees. Similar idea with D. Oh, I know what's going on here. Oh, okay, so similar idea, I would have 2 thetas minus 45 equals 90. That would give me 2 thetas equals 135. And when I divide by 2, 67.5. All right, I don't think they're going to make it more complicated than that. But if you did, okay, I'll just show you with my calculator. Okay, I see fractions. I'm not going to get freaked out or frustrated or I don't know what other choice word you want to use. Okay, I'll try and make it so you can see my keystrokes at the bottom. Alpha y equals enter gives me the fraction template. I have a third and I'm adding that to a whole. So now I know I have 4/3 pi. And if I have 4/3 pi plus 10 equals 90, I subtract 10, I get the 4/3 pi equals 80. Okay, I would multiply both sides by the reciprocal, but you could just type in your calculator 80 divided by, hit up, grab that, and that gives you the answer. Okay, so we can't just have a fraction and then suddenly we're a hot mess. We go to our calculator, we use some way to persevere through the problem. So theta for this last one was 60 degrees. Okay, so again, we see sine equals cosine. We have to tell ourselves that means the angles add to 90. I might have to use algebra to do so. All right, so that's the most that I want to talk about for day 3. Da-da-da-da-da-da. Day 4, special right triangles. What's special about a right triangle, you ask? You're about to find out. So I'm on page 16. My wife just called. She made it through the second day of school this week. Very exciting. Flu hit our house hard, but you know. In any case, um, the, the main idea of this is you're going to use it again in later math classes, and this is a shortcut. Okay, so we have two types of triangles we're going to talk about, and we usually call them by their angles. Okay, um, there is like an activity in this, whether you do it or not. I'm not going to know because I'm not there, but hopefully we try. So this says we have CA congruent to AT, and that would make this an isosceles right triangle. And we should know that if it's an isosceles right triangle, we know what the two other angles are. How do we know that? Well, we have 180 degrees in a triangle. We know we have 90, leaves us 90 left. If two sides are the same, the base angles are the same, so we divide that by 2 and poof, 45, 45. Whoa, 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 whoa. I don't know about the audio right there, got a little crazy. So we call this a 45, 45, 90 triangle. Okay, and you can kind of go through the prompts of this, but if you know you have a 45, 45, 90 triangle, we're good. And this comes up a lot also if you drew in the diagonal of this shape. And if all four sides are the same with some 90s, we got a, you said it, square. So I'm going to make like a little chart. Okay, we know that right now we know that CA equals CT. Okay, and those are both across from the 45. So I'm going to make a little chart right here. I'm going to have what two sides are across from the 45 and what's across from the 90. Okay, and we're going to put 1 in for CA, or 2, or 3, or 4. Okay, so I'd like you to pick one of them. I'll pick 4. So if I was still looking at that triangle, if I knew this was 4, I know that's 4. Okay, so that shouldn't be a huge deal. And then to find the missing side, do I use sine, cosine, tangent? Well, I don't know any angles. I know 2 of the 3 sides of a right triangle. It's just nothing's coming to me. I feel like it should be easy as 1, 2, 3, something like do, re, mi, X, Y, Z, A, B, C. Oh, B. Oh my. Okay, here we go. Okay, don't stop. The main thing we got to really make sure that we're focused on is like you're paying attention. We got to make the hypotenuse C. Okay, so for me, I'm going to do 4 squared plus 4 squared equals C squared. For you, I'd like you to pick either 3, 2, or 1, and then try the Pythagorean theorem with it. So, quick pause of the video. DJ plays the music. Pythagorean theorem. Pause it. You won't. Go. All right, so did the Pythagorean theorem. I typed 4 squared and 4 squared in my calculator. That gave me 32. It wants it in simplest radical form. If you're doing the breaking out of jail piece, that works as well. 16 is the biggest perfect square. So mine ended up with 4 radical 2. And I wonder what yours ended up with. And if there's a pattern. Maybe someone else has theirs done. They did a different one than you. What's the pattern? Maybe you want to do all of them and find the pattern. But just so we know, 45 and 45 has to be the same. And this ended up being a 3 radical 2, a 2 radical 2, and then just radical 2, or we could call it 1 radical 2. Okay? So hopefully you could see the pattern. And if I knew that, I don't know, one of the sides was 7, I would know this is 7, and then this has to be 7 radical 2. all right? Because that's the pattern that we're following and that we're working through. So I'd like you to go to page 18, 1-8, and we're going to fill this one in right here. So this is our 45, 45, 90 triangle. I'm just going to use a letter to represent one of the sides. I usually always go across from one of the 45s. Let's say I call it B. And then this would also have a value of B. And then this is always going to be that number with a radical 2 attached. I know, pretty crazy. Okay. The other one I'd like to investigate is 30, 60, 90. But before we do that, I'd like to try some practice problems. So now I'm on page 19. And listen, you could do some of these with Pythagorean theorem. You could do some of these with SOHCAHTOA. But here's the shortcut. I recognize 45, 45, 90. These two sides are the same. So that's like my B. So this has to be 8. And then this is B radical 2. So I would make this 8 radical 2. Okay? And if you followed that logic, it's all we're really trying to go at. So why don't you try 3 and 4? Give it a shot. One time. Why not? Here we go. Okay, so this time I'm given the 90. So that means 15 has to be my B value across from the 45. And this has to be 45 to equal 180, so that also has to be a 15. Number 3, across from the 45 is 60. So across from the other 45 has to be 60, and across from the 90 has to be 60 radical 2. Okay, so that's our idea with 45, 45, 90. A little bit more difficult to come up with the 30, 60, 90. Okay, but we're starting with an equilateral triangle dog. Who let the dogs out? I didn't. So all three sides are the same. They want me to draw in an altitude. What does this triangle have? Attitude? Oh, altitude. That means it's height. Okay, and we need to know a couple things about an equilateral triangle. If it's an equilateral triangle, we should know all the angles. Okay, so it's equilateral. I've heard that if the sides are the same, the angles are the same. So if I have 180 degrees with 3 angles, each angle is 60. Okay, and then next you could look at, this triangle right here. And I got 60, I got 90. So that means right here has to be 30. On the other side, I get 60, 90. That means right here has to be 30. Okay, and this also is a bisector. So both of those little pieces, D to S and S to G, need to be the same. Okay, so I'm interested to see if you know how to fill out a 3-letter system of the angles. Let's take a quick pause. I don't care if you put the P in pause or the Oz in pause, but pause it and see if you figure out which angle goes where. If you're having a hard time with this, the middle letter is where the angle is. So OSG is 90. SOG is 30. OGS is 60. Okay, so they call this a 30, 60, 90 triangle. Technically, this would be a scalene right triangle. 3 different angles, 3 different sides. Okay, so similar idea. We're going to have the side across from the 30, the 60, and the 90. All right, and we're going to be given a number. We're going to be given a number that represents O to G. So this is really my hypotenuse. This is O to G. Okay, so we're going to have a 2, a 4, a 6, and an 8. I'll do 6 this time. And if this is 6, okay, like just like up here, if this was 6, this is 6, and then both of these would have to be 3 because it's been bisected. So now I know across from the 30 is 3. And shoot, so I use trig. What do I use to figure out the third side here? I have two of the three missing sides. Uh, what's that Jackson 5 song? Do, re, mi, 1, 2, 3. Oh, A, B, C. So we got to do some A squared plus B squared equals C squared again. Absolutely correct. C is the hypotenuse. Great. So I'd like you to do this with 2, 4, or 8. Give it a pause. See what you come up with. So this time I had to subtract, and I ended up getting 27 for mine. Biggest perfect square that comes out of it is 9, or you could have broken more 3's out of jail, but this ended up giving me 3 radical 3. Okay, so the pattern continues. Hopefully you did one of these. Half of the 90 is across from the 30. Okay, and then if you did any of these, you would have gotten 1 radical 3, 2 radical 3, and 4 radical 3. Okay, so if you knew that it was 30, 60, 90, and they told you this was 10, this would be 10 radical 3, and this would end up being 20. Okay, so there's the pattern. Going back to page 18 in the bottom. So the one thing that's trickier about this is you got to recognize which one we're doing. Okay, I'm just picking a letter. Let's go with W. So I always pick across from the 30 to be my W. Okay, the hypotenuse is double that value. And then across from the 60 is that number with a radical 3. So if you were trying to memorize this, I always knew there was a radical 2 and a radical 3. Think about it like this. There are 2 equal sides for radical 2. There are 3 different sides for radical 3. So if I'm looking at the bottom of page 19, okay, looking at my triangle, here I got my 30, my 90, that has to be now 60 to add to 180, okay? So across from here is like my W. Across from the 90 would be 2 of those. In this case, I'll use X. So that makes X 20. And across from the 60 is that number radical 3. So this would be 20 radical 3. Okay, and that's just a shortcut to get around Pythagorean theorem or having to do right triangle trig. These types of triangles come up a lot as you move throughout your math career. So if I move over here to, let's go to 14, okay? Let's try 12 and 14. So quick pause, see if you can figure out what goes in those spots. 12 and 14. So if you're grasping the main idea, we're trying to figure out, okay, what is our relationship? I found that I had an angle of 30, 60, 90, okay? Across from the 30 is like my X or my W, so this is 12. This would now be 12 radical 3, and this would now be 24. Okay, over here we're given across from 60, so X is 9, and this would have to be 18. The last one that I want to do with you is this problem number 15. I'd like you to read it, see if you remember the area formula for a rhombus, and then we're going to kind of go from there. Each side of a rhombus is 14 inches long. Two sides form a 60-degree angle. Find the area of the rhombus. Round your answer to the nearest square inch. So hopefully we know a rhombus is like a tipped square. All the sides are 14. They're telling me this is 60, so that must be 60. If you really needed to know, those two would have to be 120 to add to 180 if they're adjacent. And the area of anything in the parallelogram family is base times height. Now you have to understand the height has to be perpendicular to the base. So the base must be perpendicular to the height. So I can't just do 14 times 14. I'm going to take this corner right here, and if I draw in the height of that, that makes a right triangle. And if I pulled that right triangle off, this is what I know so far. Okay, so now I know this has to be 30. All right. So if I follow this pattern Across from the 60 would be W radical 3. Across from 30 is W. Across from the 90 is 2W. That tells me W is 7, and this would have to be 7 radical 3. All right, so it doesn't really matter. I'm calling this my base, so this would be 14. Multiply it by my height, which I now figured out with a 30, 60, 90 triangle, 7 radical 3. Couple clicks on my calculator. Gives me this to the nearest square inch, so 169.7 rounds to 170 square inches. All right, so I want you to try and get through homework 3 and 4. Okay, the last page of homework 3 is tricky. Just see as much as you can get through this. I appreciate you getting after it, and you got after it. This is it. I don't care if you sit, but hopefully this math video was a hit. Stock money out.